In this video, Chain Rule Part 4, we simply have some additional chain rule examples. There are numerous ways to do the chain rule in calculus. So this time our inside function is a quotient rule. Our outside function we think of as x to the fifth power. So dy dx is equal to the derivative of x to the fifth, 5 something to the fourth power. Don't change the inside, so we have a 4x plus 1 on the bottom and a 3x minus 2 on the top. Multiply by the derivative of that inside function. So the derivative of the inside function, let's square the bottom first, so 4x plus 1 squared, and then we have bottom times the derivative of the top is 3 minus the top function, 3x minus 2, multiplied by the derivative of the bottom, which is 4. We can clean up the top of that by distributing the 3, distributing the 4. Don't forget to distribute this negative as well. So 12x plus 3 minus 12x plus 8. Our 12x's cancel out, leaving an 11 on top. And what I would probably do is go dy dx is equal to 5, 3x minus 2 over 4x plus 1 to the fourth power, and then 11 over 4x plus 1 squared. We could, if we want to, multiply that 5 in and make that a 55. I leave that up to you. Cook till done. In our second example, we have a function f multiplied by a function g. Notice that the function g is a chain problem. So we're going to be doing product rule with chain rule as chain. Let's slide this over to get a little more room, because this problem is a little more involved. So remember, product rule is f times g prime plus g times f prime. dy dx equal to our first function is x cubed. We're going to multiply that by the derivative of the second function. Let's think of this with the square there. So our inside function, sine 5x to the fourth, our outside function, x squared. So 2, don't change the inside, multiply by the derivative of the inside. Well, the derivative of sine is cosine. Don't change the inside, multiply by the derivative of the inside, 20x cubed, plus our second function, which was sine squared 5x to the fourth, multiplied by the derivative of our initial first function, which would be 3x squared. At this point, I would probably clean this up just a little bit. dy dx is equal to, if I multiply those two items together, I get 2x cubed. I've got a sine 5x to the fourth. I've got a cosine 5x to the fourth. Now I've got this 20x cubed in the back. I guess I could have multiplied that originally here. So I'm going to go ahead and do that. If I multiply the 20x cubed times the 2x cubed, I can simplify that just a little bit out front, and I would get a 40x to the sixth. Now I've got plus, I'm going to move this 3x squared out in front, 3x squared sine squared 5x to the fourth. Pretty involved problem there, so be careful. In our last example, again we have a product rule, f and g. This time both of those functions are chain rule problems. So dy dx is equal to, we have our first function, 4x squared minus 3x to the fifth power, multiplied by the derivative of the second function. So we have 4 something to the third power, don't change the inside, multiply by the derivative of the inside, plus our second function, 2x plus 1 to the fourth, multiply by derivative of the first function. So again, we've got 5 something to the fourth power. Don't change the inside function, multiply by the derivative of the inside function. We can clean this up just a little bit. 4 times 2 is 8, so dy dx is equal to 8. 4x squared minus 3x to the fifth power, 2x plus 1 cubed, plus, and then our second problem, we could probably bring this piece here. If we do that, we would get 40x minus 15, 2x plus 1 to the fourth, 4x squared minus 3x to the fourth. We could, at this point, do a little more algebra, and I'll have a separate video on this type of algebra. But what we're going to do is factor out a GCF. So let's see what we can find in both places. So in our first position and our second position, we're looking for things that are the same, and we're going to choose the lowest exponent. So let's go ahead and start with our 4x squared minus 3x to the fifth power and 4x squared minus 3x to the fourth power. The smaller exponent would be the fourth power, so I'm going to factor out a 4x squared minus 3x to the fourth power. I have a 2x plus 1 cubed and a 2x plus 1 to the fourth power. If I factor out the smaller exponent, 2x plus 1 cubed, then inside I have left over my 8, so I'm going to put an 8. I have 1 4x squared minus 3x left over, so 4x squared minus 3x, plus, in our back half, I have the 40x minus 15 left. And then I also, if I look here, I've got 1 of our 2x plus 1s left over. So it's possible that AP might do that. They also might clean up the inside, but I'll leave that to another video.